We've all been there, right? You've got this super fast computer, a real powerhouse, but suddenly it just grinds to a halt. Everything is sluggish, the mouse is lagging, and you're just sitting there wondering what is going on. Well, today we're going to pull back the curtain on that exact problem. To get this, let's start with a really simple analogy. Imagine you're at your desk studying for a big exam. You've got 3 huge textbooks you need, but you only have enough desk space for 2. So you're working away, and then you need a fact from that third book. So you have to stop, close one of the books you have open, put it away, pull the third one out of your bag, find your page, and then, of course, you immediately need something from the first book again. You end up spending all your energy just swapping books back and forth. You feel really busy, but you're not actually getting any studying done.
Well, that feeling, that frantic, busy but unproductive state, that is exactly what we call thrashing in the computer world. And it's the very same process that can bring even the most powerful PC to its knees. So, to really understand why your computer gets stuck in this loop, we first need to look under the hood at the clever and kind of magical way it manages memory. It all starts with this brilliant idea called virtual memory. See, your computer has a very limited amount of super fast memory called RAM. Think of this as your desk space. To work around this limitation, it uses a piece of your much slower hard drive as an overflow area, pretending it's part of RAM. This is the magic that lets you have, 50 browser tabs, a video editor, and a game all open at the same time, even when they wouldn't all fit in your physical RAM. The actual process of doing this is called paging. The computer breaks up all that data into little bite-sized chunks called pages. When your CPU needs a page that's not currently in the fast RAM, it creates something called a page fault. Now, I know fault sounds like an error, but it's not. It's perfectly normal. It's just a little note to the operating system that says, hey, can you go grab this page from the hard drive for me? And normally, this whole system works beautifully. But what happens when this perfectly normal, helpful process gets pushed way too far? Well, that's when we hit the tipping point, and everything starts to go terribly, terribly wrong. So picture it. Your computer's humming along, happily swapping a few pages here and there. But then you ask it to do just one more thing. You open another big program. You ask it to juggle too many balls. And that one extra task kicks off a catastrophic chain reaction. All of a sudden, there isn't enough RAM for any of the programs to have the pages they need to work. So now every single thing the computer tries to do triggers a storm of page faults. It's spending 99% of its time just swapping pages between the slow hard drive and the fast RAM. The CPU, the brain of the whole operation, is just sitting there, idle, waiting for data that never seems to arrive. And here's the truly ironic, painful twist. The operating system sees that the CPU is idle and thinks, oh, we must have spare capacity. Let's launch another program. It literally throws gasoline on the fire. And this chart shows that spiral perfectly. Look, as you add more programs, your CPU usage goes up. That's good. You're using your machine's power. You hit this sweet spot, this peak of efficiency. But if you push it just a tiny bit further, you cross that threshold. Performance doesn't just dip a little, it completely falls off a cliff. That's thrashing.
All right, all this theory is great, but let's make it crystal clear with some simple numbers. Seeing it in action really helps it click. So let's pretend your computer has 4 gigabytes of RAM, and you want to run 3 programs. To run well, each one really needs about 2 gigabytes of RAM to itself. You can probably already do the math and see where this is going. First, let's just run 2 of the programs. P1 needs 2 gigs, it gets 2 gigs. P2 needs 2 gigs, it gets 2 gigs. Our 4 gigs of RAM are now full, but hey, everybody's happy, page faults are low, and the system feels fast and responsive. This is a healthy state. Okay, now let's launch that third program. We now need 6 gigs of memory, but we only have 4. So the operating system, trying to be fair, divides the 4 gigs up between all 3. Now nobody has the 2 gigs they need. Every program is constantly missing its data. Every time one program gets a page it needs, that page has just been kicked out of memory to make room for another program's page. The page faults, they just skyrocket for everyone. And the result? Your hard drive light is blinking so fast it looks like it's solid on. The disk is working itself to death, but the CPU is just twiddling its thumbs, waiting. To you, the user, the computer is completely frozen, even though behind the scenes it's busier than it's ever been. Okay, so we get it. Thrashing is a destructive nightmare. So let's get to the important part. How can you tell when it's happening, and what can actually be done about it? The signs are actually pretty obvious once you know what to look for. The number one giveaway is that hard drive activity light. It's not just blinking, it's basically a solid beam. At the same time, the whole system feels unresponsive. And here's the weird part. Your computer's probably pretty quiet. The fans aren't spinning up because the CPU itself isn't actually doing much work. So you detect the problem by spotting that deadly combination, high disk I/O and super low CPU usage. And the solutions, well, they basically fall into two camps, having the operating system manage things more smartly or just giving the system more physical resources to work with. Modern operating systems are actually incredibly sophisticated about avoiding this. They use strategies like the working set model, which is a fancy way of saying they try to figure out the bare minimum RAM an app needs to function without constantly faulting. They also monitor the page fault frequency, and if it starts climbing too high, they can take action, maybe even by suspending a less important background process to free up memory and let the system recover. But for us, the actual users, if you find your computer is constantly in this state, the number one most effective, surefire solution is just beautifully simple. Add more RAM. Give your computer a bigger desk. And honestly, this is a huge takeaway. If you're a heavy multitasker, prioritizing more RAM over a slightly faster CPU will have a much bigger impact on your day-to-day experience. It's the most direct fix for this entire problem. So, if you remember just one thing, let it be this simple formula. Thrashing is a chain reaction. Memory overload leads to excessive paging, which causes a total performance collapse. That's it. So the next time your machine gets painfully slow when you see that little disk light going absolutely bananas, you'll know exactly what to ask yourself. Is it just busy working on a big task, or is it fallen over that cliff into a thrashing spiral? Now you'll know how to tell the difference.